Hello and welcome to another video. Let's solve this question on the board. And I read, the following nuclear equations represent two types of radioactivity. Radioactivity is a process in which nuclei of certain elements undergo spontaneous disintegration without excitation by any external means. And when it comes to radioactivity, now it is important to note that the elements whose atoms undergo disintegration to emit the different types of radiations known as alpha radiations, beta radiations, and gamma radiations are elements we call radioactive elements. All right, so we have two equations on the board. The first equation, let me interpret the first equation. The first equation is an equation, okay, in which we have the decay of radium-226 into radium-222 by emitting an alpha particle. Okay, we can also have the case of uranium-238, and this will be 92, the atomic number. Okay, when this decay is going to what? It's going to decay into thorium-234. Okay, so the atomic number in this case will be what? 90. Then by emitting what? An alpha particle. So this is alpha particle. Okay, so now the second equation, okay, we have the equation in which nitrogen 14 absorbs or is being bombarded with an alpha particle, okay, which now transmutes into oxygen 17 and a proton. That means this is a nuclear reaction. Why this one is a what? Is an alpha decay. That is a spontaneous radioactive process where an alpha particle is emitted from the nucleus. That is the first equation. But the second equation is a non-spontaneous nuclear reaction, okay, which is being induced by the bombardment of alpha particle. So which means for when it comes to nuclear reaction, in nuclear reaction, the non-spontaneous process, okay, requires external information to initiate the what? To initiate the nuclear reaction. Okay, so just like I said, radioactivity, okay, is a process in which the nuclei of certain elements undergo spontaneous disintegration. Okay, so when it undergoes spontaneous disintegration, then without excitation by any external, so without any external information, okay, radioactive process will take place. That is, it will occur. So in this case, the first equation, so we are asked to identify each type and explain briefly the difference between them. Okay, now for equation 1, here's my solution. Equation 1, that is equation A, which is the equation involving radium 226, okay, 226 with the atomic number 88. Okay, so when radium decays, okay, into radon, this is radium 222 with atomic number 86, okay, then it will emit an alpha particle. Let me use this, okay, by emitting an alpha particle. Okay, so this first equation, that is equation A, is what? Is alpha decay. Okay, this is alpha decay. So let me interpret this. Like I said, we have radium 226 decays, okay, decays into radon 222, okay, by emitting an alpha particle, okay, by emitting an alpha particle. So that is to interpret this equation. All right, so the second equation, equation B, okay, so we have the second equation, which is equation B. We have nitrogen 14, with atomic number 7, okay, is being bombarded with an alpha particle. So this is alpha particle. Okay, let me use helium. Okay, it's being bombarded with alpha particle. Okay, transmuting into oxygen 17, transmuting into oxygen 17 and proton. Okay, this is proton. So let me interpret this. So like I said, this is what? This one is nuclear. This is nuclear transmutation. This is nuclear transmutation. So this is a what? This is the reaction, or this equation is known as nuclear transmutation. That is because in this case we have nitrogen 17. Okay, nitrogen 17 absorbs alpha particle. Okay, absorbs alpha particle. Okay, that is this guy absorbs alpha particle. Okay, transmuting into oxygen, transmuting into oxygen 17 and a proton, and a proton, and a proton. So that is the first question. Identify each type. Okay, so the first equation, like I said, is an equation in which we have radium 226. Okay, when we have radium 226 decays into radium 222, emitting an alpha particle. Okay, so then in this case we have a nuclear reaction, because this is a non-spontaneous process. Okay, that is the process, okay, where one element, okay, is converted into another element through what we call particle bombardment. Okay, so that's in the case of nuclear reaction. Okay, but in this case, this is a spontaneous radioactive decay process where an alpha particle is emitted from the nucleus. Okay, so now let's talk about the difference between alpha decay and nuclear transmutation. So the second question here is to explain briefly difference between them. Okay, so for the first one, let me write number 1. Now let me explain their difference. Okay, differences between alpha decay, okay, and nuclear transmutation. Nuclear transmutation. Okay, so number 1. Now, alpha decay is a spontaneous radioactive decay process where an alpha particle is emitted from the nucleus. Is emitted from the what? From the nucleus. Okay, so this is for alpha decay. Now, when it comes to nuclear transmutation, now nuclear transmutation is a non-spontaneous nuclear a non-spontaneous nuclear reaction induced by the bombardment of alpha particle. That's number 1. Let me add one more. Number 2, Okay, now in alpha decay, in alpha decay, in alpha decay, atomic number decreases by 2. Okay, decreases by 2, while in nuclear transmutation, okay, let me put it this way, decrease by 2 because of space. Okay, so now in nuclear transmutation, in nuclear transmutation, okay, in nuclear transmutation, okay, the atomic number let me put it this way, atomic number increase or decrease depending on the reaction. So depending on the reaction, we can see here that the atomic number decreases by 2, 88 to 86. Now, so that's in the case of alpha decay, and that's what we have here. It decreases by 2, but in this case, it depends on the reaction. Okay. Now let's take number 3. Now, in the case of alpha decay, okay, alpha decay occurs naturally. Alpha decays occur naturally. Okay, while nuclear transmutation, okay, while nuclear transmutation requires external means to initiate the nuclear reaction. That's it. To initiate the nuclear reaction. Okay. Now that is because in alpha decay results in a more stable daughter nucleus. Okay. But in the case of nuclear transmutation, it will result in different elements, okay, often with different stability. Okay, so that's in the case of nuclear transmutation. So nuclear transmutation, okay, is a process where one element is converted into another element, okay, through particle bombardment to make it more easier. Or we can say that nuclear transmutation is a non-spontaneous nuclear reaction, okay, nuclear reaction induced by bombardment of alpha particle. And these are the answers to this question. And with that, we've come to the end of this tutorial. The quality of your preparation will always determine the quality of your performance. So get started. Bye-bye.